Hello friends, welcome to Systematic Physics. Here we will be guiding you for content of physics for boards, NEET and JEE. So let's start. Welcome to the competitive exam corner of rotational motion. Here we shall discuss the MCQs in two segments, level 1 and level 2. Let us start with the level 1 MCQs. Now before I go for that, you got to know some formulas which are used. Now you need to locate the position vector of a particle, that is the center of mass. That formula is R bar is equal to M1 R1 bar plus M2 R2 bar plus M3 R3 bar plus dash 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 till Mn Rn bar upon M1 plus M2 plus M3 till Mn. Now position of center of mass of two particle system. Now suppose if the system has two particles, you know position vector of both these particles. Then how would you locate the center of mass of these particles? R bar is equal to M1 R1 bar plus M2 R2 bar upon M1 plus M2. Now in this case, suppose if M1 is equal to M2, then M will get cancelled from numerator as well from the denominator, and you will be left with R1 bar plus R2 bar upon 2. Now there are some important points about center of mass. Listen to it very carefully. The position of center of mass is independent of the coordinate system chosen. Means however you select the coordinate, the position of center of mass does not change. The position of center of mass depends upon the shape of the body and distribution of mass. For example, if some part of the body is heavier, the center of mass tends to move towards the heavier part of the body. The distribution is uneven. Center of mass would be always closer to the part which is heavier. Remember this point. The center of mass changes its position only under the translational motion. There is no effect of rotatory motion on a center of mass of the body. If a system of particles of masses m1, m2 move with velocity v1, v2, then the velocity of center of mass is summation I going from 1 to n mi vi upon summation of mi, the expression which you can see on the screen. If a system of particles of masses m1, m2 move with an acceleration a1, a2, then acceleration of the center of mass would be summation I going from 1 to n mi ai upon summation of mi. Let us see the problem based on center of mass. Now suppose velocities of three particles of masses 20 gram, 30 gram and 50 gram, okay, are 10 I cap, 10 j cap and 10 k cap respectively. Then what would be the velocity of a center of mass? Options are right in front of you. The solution would be this. Velocity of a center of mass is m1 v1 plus m2 v2 plus m3 v3 upon m1 plus m2 plus m3. M1 known to you, V1 known to you, M2, V2, M3, V3, everything known to you. Put all those values in the expression. Then you get velocity of a center of mass is 2i cap plus 3j cap plus 5k cap. Let us see the next problem based on the same concept. Masses 8 kg, 2 kg, 4 kg and 2 kg are placed at corners A, B, C, D respectively of a square ABCD of diagonal 80 cm. The distance of a center of mass from A will be. The options are right in front of you. Let's see the solution which is there in the next slide. Now see, they are asking distance from point A. So consider point A as the origin. If they say distance from point D, then you will choose D as the origin. And likewise for B and C. See the diagram properly. Point A 8 kg. Point B 2 kg, point C 4 kg and point D 2 kg. It is resting in the xy plane as shown in the figure. And A is my origin. Reason? Because they are asking a distance from point A. Now the diagonal is equal to A into root 2. A is a side, isn't it? Now what would be the coordinate of point A? It will be 0, 0 since it is the origin. So how do you write that in a vector form? 0 I cap plus 0 j cap. R2 is for point B. Can you see that point B is lying on the x-axis? So its x coordinate would be equal to side of the square and its y coordinate would be equal to 0. So R2 bar would be equal to AI cap plus 0 J cap. can you not see that third particle 4 kg? It is equidistant from both the axes. So its coordinates are a comma a. So that position vector would be equal to ai cap plus aj cap. Last particle, that is point D, it has got 2 kg mass. It is lying on the y-axis, so its x coordinate is equal to 0. And y coordinate would be equal to the side of the square. What is it? R4 bar would be equal to 0 I cap plus aj cap. Now, you know all 4 masses, right? M1, M2, M3, M4. You know all 4 position vectors, that is R1 bar, R2 bar, R3 bar and R4 bar. You have formula available with you. That is R bar is equal to M1 R1 bar plus M2 R2 bar plus M3 R3 bar plus M4 R4 bar upon M1 plus M2 plus M3 plus M4. Put all the values. Then what do you get? R bar is equal to 15 root 2 I cap plus 15 root 2 j cap. Now something very important would start. Now this is a position vector and you have to find out the distance of this particle from the origin. You have a distance formula. What is the distance formula? Square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now what is x2? Your x2 would be equal to 15 root 2. Your y2 would be equal to 15 root 2. Your x1 is 0 and y1 is 0, which are coordinates of point A. I hope you understood. I put all the values and I get distance equal to 30 centimeter. Now, third problem based on the same concept. I hope you understanding. I am slowly keeping the concept same, changing the module of the problem. The coordinates of the positions of particles of mass 7 gram, 4 gram and 10 gram are 1, 5, minus 3, 2, 5, 7, 3, 3, minus 1 centimeter respectively. The position of the center of mass of the system would be. Now, they have given you M1, M2, M3, right? They have given the coordinates of the point. The coordinate of a first point is 1, 5, minus 3. So its position vector would be R1 bar is equal to I cap plus 5j cap minus 3k cap. R2 bar, you can see the position vector of the second point would be 2I cap plus 5j cap plus 7k cap, because the coordinates of point 2 are what? 2, 5 and 7. Now see third position. That is third particle, that is 3I cap plus 3j cap minus k cap. Now again formula you have R bar is equal to M1 R1 bar plus M2 R2 bar plus M3 R3 bar upon M1 plus M2 plus M3. Substitute all values in the formula, you get the answer. R bar is equal to 15 by 7 I cap, 85 by 21 j cap minus 1 by 7 k cap. Now, if this is the position vector, then what are the coordinates of the center of mass? Come on, simple. What is it? X coordinate is 15 by 7, its y coordinates is 85 by 21 and its z coordinate is minus 1 by 7. Those were the problem based on the position of a center of mass. Now we'll see the equations of linear motion and rotational motion. See, you have to see across the table. I'll read first point of linear motion, then I'll read the first point of rotational motion and explain you the analogy between the two. S is a linear displacement, would be replaced by what? Theta, which is angular displacement. So theta is equal to omega 1 plus omega 2 by 2 into t. U is replaced by omega 1, V is replaced by omega 2. I hope you understood the analogy between the two. Now, go for the next expression, that is linear acceleration A is equal to V minus U upon T. Angular acceleration alpha would be equal to omega 2 minus omega 1 upon T. Now, if I change this expression, that becomes V is equal to U plus AT. That same expression would become omega 2 is equal to omega 1 plus alpha T. S is equal to ut plus half at square. The same expression in rotational motion would become theta is equal to omega 1t plus half alpha t square. V square is equal to u square plus 2as. V would be replaced by omega 2, u would be replaced by omega 1, a would be replaced by what? Alpha, and s would be replaced by what? Theta. So it is omega 2 square is equal to omega 1 square plus 2 alpha theta, right? Now, distance traveled by the particle in nth second would be equal to u plus half a 2n minus 1. Similarly, in rotational motion, it will become what? Theta n, that is omega 1 plus 2n minus 1 alpha by 2. I hope you understood this. Let's go for the next set. Now, how will you use the derivatives in linear motion and in rotational motion? V is equal to dx upon dt. Omega is equal to d theta by dt. A is equal to dv by dt, and that is equal to V is replaced by d2x by dt square, right? Now same thing I'm converting into the rotational motion. V is replaced by omega, x would be by theta. So omega is equal to d theta by dt. A is equal to dv by dt, d2x by dt square. Come on, tell me without looking to the right. Alpha would be equal to d omega by dt. That omega would be replaced by what? D theta by dt. So the expression becomes d2 theta by dt square. Now see the last expression. V into dv is equal to a into ds. If I have to replace that equation in case of rotational motion, it would be omega into d omega, that is equal to alpha into d theta. Now, problem based on angular displacement, velocity and acceleration. The wheel of a car is rotating at the rate of 1200 revolutions per minute. On pressing the accelerator for 10 seconds, it starts rotating at 4500 revolutions per minute. The angular acceleration of the wheel is, now see, alpha would be equal to rate of change of angular speed, that is omega 2 minus omega 1 upon t. Now you know, once the things are given in RPM, you need to convert in RPS, that is revolutions per second. To convert that into RPS, you will divide by 60. So what is the expression? Omega 2 would be 2 pi n2. Omega 1 would be 2 pi n1 upon t. So that is 2 pi n2 minus n1 upon t. Substitute all the values given in the problem. You get the answer as what? 1980 degrees per second square. Problem number 5. The wheel completes 2000 revolutions in covering a distance of 9.5 km. The diameter of the wheel is. The distance travelled in 2000 revolutions would be equal to 2000 into the circumference of a circle, that is pi into d. So once you put that formula, d is equal to 1.5 meter. Problem number 6. The wheel is at rest. Its angular velocity increases uniformly and becomes 60 radians per second in 5 seconds. The total angular displacement of the particle is. Now you know the formula, alpha is equal to omega 2 minus omega 1 upon t. Omega 2 is 60 and omega 1 is 0 because it's starting from a rest. So you got a value of alpha. Now you need to find out the angle turned. What is the formula for theta? That is equal to omega 1t plus half alpha t square. Put omega 1 is equal to 0. Put alpha is equal to 12, which you found out. T is 5 seconds. After putting all the values, you get theta is equal to 150 radians. So option D is the correct answer. If the position vector of a particle is r bar, that is equal to 3I cap plus 4j cap meter, and its angular velocity omega bar is j cap plus 2k cap radians per second, then its linear velocity in meter per second is. For this, you have to recall some formula from circular motion, where I say V bar is equal to omega bar cross r bar. Now omega bar is 0I cap plus j cap plus 2k cap, and r bar is 3I cap plus 4j cap plus 0k cap. So when I multiply this, I get, how do you open this bracket? I cap, omit that whole row and that column. What is left? 4, 0, 1, 2. So 4 into 2 minus 0 into 1. Second is minus j cap, omit that row and the column. So 3 into 2 minus 0 into 0. Last one is plus k cap, omit that row and the column. So 3 into 1 minus 4 into 0. So when I put all these values, I get V bar, which is equal to 8I cap minus 6j cap plus 3k cap. Can you tell me which option is correct? Option A is correct. Linear velocity is always radius into angular velocity, and linear acceleration is radius into angular acceleration. Now, moment of inertia. It is a property of the body due to which it opposes any change in its state of rest or uniform motion. Moment of inertia for a particle is I, that is equal to m into r square. Moment of inertia of a whole body, if you want to find out, that would be equal to m1r1 square plus m2r2 square till mn square. Now if it is a uniform distribution, then I is equal to integral of r square dm. What is radius of gyration? Radius of gyration of a body about a given axis is the perpendicular distance of a point from the axis where if the whole mass of the body were supposed to be concentrated, the body shall have the same moment of inertia as it has with the actual distribution of the mass. Suppose if I replace the whole body with the help of some point mass whose mass is same, say capital M, then moment of inertia I is equal to m into k square. So k would be equal to square root of I by m. I hope you know what is parallaxis theorem. Diagram shows that I is equal to Ig plus m into a square, where m is the mass, total mass of the body, and a is the distance between the two parallel axes. Parallaxis theorem is applicable for a rigid body. Perpendicular axis theorem, what is the statement? Iz is equal to Ix plus Iy. Perpendicular axis theorem is applicable only for the plane lamina. Now moment of inertia of two masses about center of mass. Now there are two masses m1 and m2 at a distance of what? r1, r2 from the center of mass. We know r1 plus r2 is equal to r. So now we know one formula that the moment about the center of mass would be always what? Same. So m1 into r1, that would be equal to m2 into r2. Now if I substitute r2 as equal to r minus r1, I get r1 is equal to m2 upon m1 plus m2 into r. So r2 is equal to m1 upon m1 plus m2 into r. Now if I substitute these values in finding out the total moment of inertia, that is equal to m1 r1 square plus m2 r2 square, I get that I is equal to m1 into m2 upon m1 plus m2 whole into r square. Now analogy between the translatory and rotatory motion. Again, translatory motion, mass is capital M, rotatory motion, mass, rotational mass is moment of inertia, that is I. Linear motion, P is equal to mv, that is linear momentum I am talking about. Angular momentum, L is equal to I omega. Force in translatory motion is equal to m into a. Torque in the rotatory motion, tau, is equal to I into alpha. Kinetic energy is half mv square. In rotatory motion, kinetic energy is equal to half I omega square. E is equal to P square upon 2m. From the above expression I get. So here E is equal to L square upon 2I. Problems based on moment of inertia. The moment of inertia of a uniform circular disc about diameter is I. Its moment of inertia about an axis perpendicular to its plane passing through a point on its rim will be. They are talking about an axis perpendicular to its plane and tangent to the rim, that is IT1. How would you do it? Moment of inertia of a disc about its diameter is equal to 1 by 4 mr square, that is equal to I. So mr square is equal to what? 4I. Now moment of inertia of a disc about an axis perpendicular to its plane passing through a point on its rim would be 3 by 2 mr square. Now mr square is known to us, that is 4I. I substitute that value. So the answer is 6I. So option B is the correct answer. 4 thin rods of same mass m and same length L form a square. Moment of inertia of this system about an axis through center O and perpendicular to its plane is. Now see, you know what is moment of inertia of a rod about its centroidal axis, that is 1 by 12 ml square. Now if any such rod if I consider and its moment of inertia I want to find out about O, then I'll use parallaxis theorem, that is ml square by 12 plus m. What is the distance between P and O in this case? L by 2. So that L by 2 would come there. So moment of inertia of a single rod about O would be equal to ml square by 12 plus m L by 2 the whole square. That becomes 1 by 3 ml square. Now how many rods we have? This is moment of inertia of one rod. How many rods do we have? 4. So multiply by 4. So I get moment of inertia of the system is 4 by 3 m into L square. 3 rods, each of length L and mass m, are placed along XYZ axis in such a way that one end of each of the rod is at the origin. the moment of inertia of this system about z-axis is? Come on. What is the moment of inertia of one rod about its end? That is ml square by 3, right? Now they are talking about moment of inertia of the rod about z-axis. Now see rod number 3 which is along z-axis. Moment of inertia of that rod would be equal to 0. Why? Because it is lying along z-axis, so its distribution about z-axis is equal to 0. So moment of inertia of the system about the z-axis would be moment of inertia of rod 1 and rod 2. That is ml square by 3 plus ml square by 3. That is 2 ml square upon 3. Two identical rods, each of mass capital M and length L, are joined in cross position. The moment of inertia of this system about a bisector would be, 4 options are there in front of you. The moment of inertia of a system about an axis which is perpendicular to the plane of the rods and passing through the common center of the rods would be equal to what? Come on. One rod ml square by 12, second rod ml square by 12. So Iz would be equal to ml square upon 6. Now again from perpendicular axis theorem, what do we have? Iz is equal to Ib1 plus Ib2. Now see the distribution of the masses about B1 and B2 would be same. So both the moment of inertia would be same. So Iz is equal to 2Ib2 or 2Ib1, whatever. And I know what is Ib1. That is what? ml square upon 12 multiplied by 2. So it becomes ml square upon 6. I hope you understood. So what is the moment of inertia about Ib1 or Ib2? It's the same thing, that is ml square upon 12. One law you remember, the moment of inertia of the rod or whatever forming a plane, if two axes are mutually perpendicular to each other, the moment of inertia always are equal. This completes the level 1 first part. Now we shall see level 1 part 2 in the next video. Please like and share the video with your friends and subscribe to stay connected with systematic physics. Thank you.